Hello, everyone. My name is Parashuram, and as Tom just said, you guys can call me Ram. I work at this company called Microsoft. You must have heard of it, as a program manager. Now, for those of you who are curious, a program manager is just a fancy title for a developer who gets to work on a bunch of interesting experiments, some of which I'm going to share today. Uh, I'm also a committer in the Apache Cordova project and have been building tools for mobile application development for a while now. And more recently, I've been building tools for React and React Native, typically things like code push and the VS Code debugger for React Native and things like that. So today I'm going to be talking about DevOps for React Native, or at least that was the title when I started working on the talk. And one evening, my wife came to me and asked me, what am I doing? And I told her, and she kind of was confused. Now, to set some context here, my wife is a research scientist, and she's attended her fair share of academic conferences where probably the title of the talk itself takes the first 5 slides. So when I told her that I was going to talk about DevOps and code push at React Conf and React Native, she was confused. She was like, are you sure this is a real thing? Are you not just making up words? So, to feel a little bit more self-important, I decided that at this international convention of JavaScript practitioners using React and React Native for building mobile applications, aka React Conf, I'll be talking about web-like development and release agility for React Native. Hey, look, I even added a subtitle just to make it even more fun. Anyway, so the thing I love about React Native is the fact that all the code that you write, all the components that you have, are actually native. However, it still has the web-like development feel for it, because all of your code is in JavaScript. And not just any JavaScript out there, it's actually JavaScript with React. And React and JavaScript combined together run inside a JavaScript virtual machine, making this setup seem very, very similar to a browser. Now, if you had to draw parallels, the JavaScript core here would probably be similar to V8, the Chrome's JavaScript engine, or Chakra, which is Edge's JavaScript engine, which sends actions over to the native UI, the native renderer, which probably is like WebKit or Gecko, and then the native engine sends events back. In fact, it's so much like a web that you even have a bundler like Webpack. In fact, it's actually better than the web, because in this case, it's like Webpack without writing a Webpack config file. Now, isn't this paradise? Like a browser without any browser war, Webpack without Webpack config. Life is awesome, isn't it? I mean, that's what is React Native. In fact, with React Native, you just start the packager, and everything works. Oh, wait, that shouldn't have happened. OK, let's pretend that never happened. It mostly works. Anyway, so the packager is something that runs on your local machine, and it picks up the source tree or source code or source files from your local machine, bundles them together, and sends it to the JavaScript virtual machine to compile them. Now, let's spice up things a little bit. Why should the packager really run on your desktop? What if the packager ran on the cloud? And every time you have a change, you bundle it on your local machine, send it to the packager, and the packager can actually live update your code on a real running device. In fact, if you have more changes, you can continue doing that, continue sending it over. It's very, very similar to live reload, or this is typically what you do with websites, right? Now, this is pretty much how you write websites, except it's not running on a browser. It's actually running using a React Native application. You can keep doing this and keep pushing updates. And in fact, if an update has an error, you can just roll back. Well, guess what? This is actually possible in React Native, and for all of you who have used code push, this is exactly how code push works. You can update your apps using code push over the air without having to wait for any process, and you can fix bugs very, very quickly. And for those of you who may be concerned about, hey, is this really legal? Here's a link from the iOS developer program information that says that as long as the code is running in JavaScript core, it is legal. As long as you do not change your application's functionality drastically, it is legal. And if you remember, a couple of days ago, there were a flurry of apps that seemed to have gotten rejected from the App Store. Now, just to clarify there, those products were using something called rollout and JS patch. We have not heard any rejection notices either for CodeFlow or for Exponent for that matter. And React Native does not expose any of those functions that were listed in that. So there were 4 functions that were questioned by Apple. React Native doesn't expose any of them directly to JavaScript. So this is actually legal, and we have people who are using code push in production. Now, code push is actually a great way to distribute your code. But every time we've been talking to code push customers, people who have been using code push, what they have told us is code push is just one simple way of distributing code. There are a ton of problems that surround it. There are a ton of things that are around code push, like code push fixes distribution, awesome. But that's not just the only thing I do in my DevOps pipeline. I also take care of, I'll have to worry about building it, continuous integration. I have to run test cases. Let's just pretend that we write tests, okay? So I have to pretend like our tests run. And the worst of it all, I have to take care of signing. How many of you here love signing your apps? I hate signing my paper checks. Signing apps is like a completely different thing. So these are all problems surrounding DevOps. And this is not just it. There are a bunch of other things that you really need when you're writing a mobile application. You need push notifications, authentication, crash reporting, and storage. We did realize that, and this is painful. And what I've been working on for the last 1 year is putting it all together, and we released a product called Mobile Center. Mobile Center is live right now at mobile.azure.com, and it's a full end-to-end DevOps workflow for you to deliver apps that your users love. And this is like a quick way to set up the DevOps pipeline. Let me actually show you how it works. So I'm going to open up my browser. Despite the name saying Microsoft and Azure, you can actually log in using GitHub. So I'm going to do that. And I have a couple of apps running. Let me just go into this iOS React Conference app. I'm going to open it up, and I can click on Build. And I already have a build running, so let me just show you the configuration for this build. So I can say, here's my package.json. This is all you need to set up. This is all you need to enter to set up a continuous integration for React Native. You just upload your certificates. You just type in your password. You can even say, hey, I want to run my jest tests. You can also say, once the build is ready, I want to distribute my build. And every time you make a code push, or every time you push something in your GitHub repository, this automatically kicks up, and the build starts. I kind of cheated there. So let me actually go ahead and create a brand new app and show you how easy it is. So I'm going to go here and say Add New. I'm going to add a new application. Let's call it Android React Conf 17. So one thing to notice is, because React Native lets you write iOS and Android apps separately, you can actually separate them right here. And each of them will have their own capabilities. However, I can share the same code base. So I'm going to say this is an Android application. I'm going to say it's a React Native application and say Add a new app. Once the app is added, I'm going to go ahead and set up the build. For now, I'm going to select GitHub. We support GitHub, Bitbucket, and a bunch of other integrations are coming. So I'm just going to select GitHub. And the app that I created was called Lunch App. Yeah, it's lunchtime, right? So Lunch App. I select this. And this is basically, as soon as it loads up, what it's going to do is it's going to ask me to set up my branch. So here's the master branch. I'm going to say, hey, go ahead, set up my master branch. Most of the values are pre-populated. I just say, I did add like 2 jest tests, so give me some credit. So I'm going to say yes, run unit tests. I'm going to say sign my builds, yes. The thing is, I don't want to use Gradle to sign my builds because my Android certificates are secrets. So I'm going to say, no, I don't have it set up in Gradle. Instead, I'll just upload this file. So I'm going to go into my workspace, find out where my files are. This was the file. I'm going to add the Android key store file, type in my super secret password, which is 123456. I just said it aloud because so that I don't make a mistake here. I mean, it's going to be a mess of a demo if I type my password wrong. So finish setup. And that's it. My build is ready. So this is all you need to do to set up a React Native application. If you have a React Native application today, I'd actually encourage you guys to go try it out. That's all. Let's actually quickly look at what the iOS app is doing. So the iOS app build should have started. Yeah, there. So it's continuing to build, and I'm just going to wait for this build to complete. And while this build is going on, let me talk about a couple of other things. So as I said, we also have support for crashes. We have support for analytics. We also have this pretty interesting thing where you can test your application in real-world devices. Now, if you guys remember, a few months back, TaskRabbit actually had a pretty amazing blog post about integration testing React Native applications. And I thought that was actually a pretty cool way to do it. So here what you can do is select your devices. Like, these are real devices you can select. I'm going to select these devices. And I'm going to select Appium, and that's what TaskRabbit recommended. So I'll encourage you guys to go read the blog that TaskRabbit said, but Appium is a pretty good way to do it. And I'm going to say next. And then it has instructions on how to write your Appium tests and how to run them. Because I have my build kicked off, I'm just going to say cancel. But let me go back to my slides and talk about testing a little bit more. So testing can get a little hard because there are devices, there are multiple types of devices. It's probably not as much a pain in iOS, but on Android, the device or the screen sizes are huge. And unlike a browser, you can't like just have an iPad and then shrink it down and shrink it back up. So testing your application on multiple devices is a little hard. And what's interesting is on the web, you have ideas like browser sync, which mirror your user gestures across multiple browsers, right? You don't have something similar on the mobile phones. Interestingly, React Native actually lets us do it. So let's take a peek inside what JavaScript core exposes. So whenever an event comes in from the native UI, it passes through something called a plugin registry. This plugin registry sends all of this information through a set of plugins. From what I've heard from the React folks, looks like the amount of plugin code is actually much, much more than the amount of the reconciler code. So this is all about normalizing your events, capturing it, bubbling it, everything like that. It sends it through an event emitter, and finally your on-click handler or your on-press handler gets called. This is true for both React Native and React. Now what you can do here, interestingly, is you can trick it and add a custom event plugin. Now, this custom event plugin is very, very dumb. It's not going to do anything specific about passing events or normalizing it. It's just going to send that event to a server. And that server can then propagate these events and inject it to other event emitters. And this way, what you can do is if you start clicking on one device, all the other devices are going to follow. Let me show you how that will work. So I have my terminal here. I have a server. This is a very, very simple WebSocket server. All it does is it receives an event and broadcasts it to other devices. I have two simulators working here. So you guys can see my, oops. This is my iPhone 7 Plus. This is my iPad. Both are completely different sizes. But what I can do now is I can interact with my iPad. And you can see that though my mouse is on the iPad, the iPhone is clicking. So like, look at this. And I can click on buttons, and this way what you can have is you can have like a bunch of devices or a virtual device wall, and just click on one and all of your devices will start working. And this is a super easy way to do manual testing. You don't have to limit this to manual testing. What you can do is, what if one of the clients is not a phone, but a command line tool? So I have this command line tool called a recorder. Here's the recorder. It's again a very, very simple thing that takes the events, stores them in a file, and then lets you replay them. You can say record, and here the third client got connected. And what this is going to do is every time I click on something, those events are going to get recorded. And then I can play these events back, and what I have is something like a record and replay testing. Now, if you guys remember how Selenium became popular, Selenium is popular because you can actually record stuff using Selenium IDE, right? It's not possible to do on a native Android app or a native iOS app. React Native is uniquely positioned to do it, primarily because of the event system that we described. Now, I just got an email. OK, looks like, so here's my phone. I got an email saying the build is successful. Let me go back to the build to show you that I'm not lying. I mean, it's a live demo. Things can go wrong, right? But yeah, there. So the actual build happened. I get an email. Here's my phone. That's what I'm holding on my hand. And I just have like QuickTime mirroring the phone screen. So I'm going to go open up my email and say, yep, that's a new email that says iOS is ready. I can click on See Details. And I'll be taken to the page where I can install my application. So I'd say install. And what happens here is a brand new build of my application gets installed. Now, if you guys have ever used Hockey app, or if you have used a test flight, this is actually Hockey app. This integration is into Hockey app. So you didn't have to set up anything. You just said, hey, once the build is ready, go start distributing it, and my app is ready. I'm going to click on this. This is something that you'll have to do because this is the first time I'm installing the app. I'm going to have to go to Settings, General, Device Management, and just trust this guy. Say, yes, I'm the developer. I know what I'm doing. So let's start the app up. Now, here's your app that was built on the cloud with just some simple configuration, and it's the exact same application. I can do the same things like move it around. I can say, I want to buy this stuff. Sure, it looks good. Maybe this time let me give it a tip. Oh, wait, something is broken, isn't it? The subtotal looks weird. Make payment. Whoops, the app crashed. That's embarrassing. OK. That shouldn't happen in a live demo. Let's try that again. Yep, Yeah, the subtotal is weird, and if I say make payment, okay, that's weird. But you know what? I actually have crash reporting software installed on my device. So let me go back to my. I was just kidding. So let me go back to my application, and if you look at my package.json, package.json, I have this thing called Mobile Center Crashes and Mobile Center Analytics installed. And because I have this analytics and crashes installed, what I can do now is go back to Mobile Center, go back to crashes, and I'll be able to see what exactly crashed my application. Now the good thing is, though this is a fully native mobile application, because this is React Native and because Mobile Center has full support for React Native, not only do I get native stack traces, I actually get JavaScript stack traces. In fact, it's not just any JavaScript stack trace, it's directly to your source file. So while we are building it, we actually generate source maps. And that way, your stack is directly linked to where exactly the error happens. So now that I know where the error is, let me start debugging it and try to see if I can fix this error live. But before I get there, let's talk a little bit about debugging. And this is something that's super clever, that I think was super clever that the Facebook guys did. So let's go back to that diagram where we were talking about the architecture diagram, right? Let's go back to that. And let's look at what really happens when you debug. So in a typical scenario, if you start debugging, you would want to attach your debugger to JavaScript core. But unfortunately, though you can do it on iOS, you can't do it on Android, because the Android JSC is not compiled to accept debug connections. So this is not possible. So what can you really do? And this is where the guys who developed the debugger at Facebook actually came up with a super clever idea. You know what? The JavaScript core, the JSC, that can run JavaScript. Who else can run JavaScript? Your browser, right? And what does the browser have? DevTools. What if you're able to run the JavaScript that's running on your phone, rather than running it on your phone, run it on the browser? And that's exactly what they did. So if you shake your phone really, really, really hard enough, like if you shake it down like a boss, you can convince it. You can convince it to say, "Hey, core, don't think about my JavaScript core. Run all of the code in Chrome, and I'm going to use the Chrome debugger for debugging." And this is exactly what most of you use with React Native. You shake your phone, you say debug.js remotely, and you start debugging it in Chrome. Now, JavaScript core can run JavaScript. Chrome can run JavaScript. Who else can run JavaScript? If you are as old as me, you'd probably say the Firefox Rhino engine, but the most modern day answer is Node, right? So that's what I did. So what I did was, instead of letting Chrome run JavaScript, I replaced Chrome with Node. So I didn't have to do anything at all. I just said, rather than starting up Chrome, start up Node. And what can debug Node? VS Code, Atom, Eclipse, WebStorm, and a whole bunch of IDEs. So rather than having to debug in a developer tools on Chrome, you are now able to debug your React Native applications in an IDE of your choice that can just support Node debugging. Guess what? Node runs on V8, right? V8 is a JavaScript engine that powers Chrome, but Chakra is another JavaScript engine that powers Edge. The Chakra team recently released Node Chakra. Node Chakra is basically, instead of running Node on V8, you run Node on Chakra. So I replaced Node with Node Chakra just to make things a little more spicy. And let's see what we can actually get with this kind of a contraption. I mean, I'm sure by this time you're like, wait, this is way too many things. It's like building like a pack of a card house, and anything can fail, right? So let's see what we can do with this. So what I'm going to do is I'm going to cancel this guy. I don't need this anymore. Exit. I'm going to go in and start. So I'm going to, rather than just starting a Node process, I'm going to say Node Chakra. Like, that's the only difference, nothing else. And I'm going to run this program called debugger.js. Before I do that, let me show you what debugger.js is. I mean, you won't believe how simple it can be. Debugger.js is exactly the same code that you see if you open up Chrome and you have a debug worker.js. This is exactly the same code. But rather than running it on Chrome, I'm going to run it on Node Chakra. So / Node Chakra, yeah. And then if I open up my, actually, you know what, let me close this guy. I don't need the simulator. I have my other simulator running. So if I say Command D, which is like shaking the phone on your desktop, and then you do this, all of my debugging actually starts happening here. And then I can do the exact same operation of like clicking through stuff. And if you see all of my console.log statements, so this uses the new React navigation library. Did I call, is it React navigation? Yes, it is. It's not React Navigator, it's not navigation, React, it's React Navigation, yeah. So, sorry, I just get confused. So, it does show you all of these logs that the new navigation library shows up. And like I can keep doing stuff, and this was the guy who caused the crash, right? So yeah, there was some issue here, and if I say make payment, so it looks like the crash is happening locally. So this was a mistake that I made, thanks to my writing this code at 2 o'clock last night. But yeah, so something went wrong, and I can say, okay, I don't want this, but yeah, it all works. So what we did see was, if I go back to my stat trace, it was service.js line number 52. That's where the error was. So let me go back to my VS Code, and because VS Code can debug Node, I'm going to just use VS Code to debug it. And hey, someone already put a breakpoint on line number 52. Yeah, so that's line number 52. I put a breakpoint. Now what I can do is I'm going to hit F5, or I'm going to say I'm going to more likely go to the debug menu and hit run. So what this is going to do is this is going to start up my debugger. And again, it's the exact same code that I wrote, but rather than running Node, I'm running Node Chakra. And it's going to start, let me just close this guy. It's going to start working, and it is in service.js. So look, what was the error? The error said, what did the error say? It said, this.total.toFixed is not function. Why is that? This.total.toFixed was not a function. Oh, that was because total was a string. Now, strings do not have a toFixed function, right? So that's a problem. Now, I'm at this function, and if I want to now go back and see who set the calculate total value, or who set the value for the total, it'll be hard, right? So I'll have to like restart the breakpoint. And this is where I started using Chakra. So unlike having to like restart it, I'm going to go back in time. I'm serious, I said that. I'm going to go back in time. So Node Chakra has this thing called, so typically what you do is if you have a breakpoint, you'd go forward, or you'd go into or go out. But I'm now going to step back. And it's going to take a while to calculate where it needs to go. But here it's starting to go back in time. And as it continues going back, I can try figuring out what really happened and who was actually setting all of these errors. Let me stop this packager, and I exactly know where the error was, so I'm not going to pretend like I don't know it. The error was actually in index.js. No, it was in purchase screen.js. It was in purchase screen.js, and it was at this place where I was trying to say this.state.tips. This, unfortunately, is it's a string, right? I mean, what a text input gives you is a string. It's not a number. So another lesson learned, use TypeScript or Flow. It'll make your life easier. You probably wouldn't even have to hit this. But here what I can do is I can say parse int, comma 0, and save this. And once I save this, I'm actually all good. What I can do here is, but you know what, my application is already on the phone, and I don't want to kick off another deploy. Like it'll take its whole native build and deploy it here. What if this was on the store? It would be a problem, right? Code push to the rescue. I'm guessing you now know that I pretty much made all of this up, but code push to the rescue. What you can do with code push is you can say code push release React, iOS React Conf, and then hit enter. Code push will bundle all of this critical bug fix so that you can actually take payments in your application. And once you set this up, you'll be able to run this whole thing, and once this is complete, your application will be available here. So while code push is doing its stuff, let's go back to the slide deck, and I'm sure you're curious about how does time travel debugging really work, right? So let's look at that. If you peer into the JavaScript VM, your application has a state. Now, this is very simple. So how many of you here use Redux time travel debugging? A good number. This is actually not very different. The only difference between Redux and what we do here is Redux only cares about states and actions. However, rather than just caring about states and actions, what if we care about the entire JavaScript context? So rather than snapshotting your state or your context, let's snapshot your entire JavaScript context. And guess what? Because it's Node Chakra, you can snapshot your entire JavaScript context. So you do that. You'll run your code as your code just runs, and then there'll be an external event, which is basically the click that I did. Now, this external event is the only non-deterministic action in this entire thing. And because it is non-deterministic, I'm going to log it around. And then I'm going to continue running my code. It says set the state, which manipulates the memory, sets the state, and then continues running. Now, at this point of time, the program counter is at that statement. Wait, did I just say program counter? I'm sorry, I'm like really old. It's probably like execution flow or whatever. Program counter is more like a C, C++ kind of a thing. But my instruction, like wherever the last instruction that was running is at that point. Now, if I want to go back in time, what I do is, there's no undo functionality here, right? However, there is a snapshot. So time travel debugging works like it works on Redux, which is go back to the previous known snapshot, run all of your code, so restore that snapshot, run all of your code, and then the time when an external event comes in, don't actually wait for the external event. Pretend as if the external event already happened, so that the whole thing is deterministic, and then continue running your code. And this way, you'll actually go back to the previous place where your code was running. So this is super similar to what Redux does, just that it does it for the whole JavaScript context rather than just for, so in a way, the event here is like a Redux action. And this is how you would be able to like jump back and forth and be able to debug your code. Now, Chakra time travel debugging is available today even for Mac. So Node Chakra is actually downloadable for Mac today. So you should be able to use it with VS Code right away. And Node Chakra was initially built for debugging applications running on a Node server with Express.js modules. I figured, why just limit all the fun to server-side guys? Let's bring it over to React Native, right? And that's how this works. Is code push done? Looks like code push is done. Let me open up my app. This is a quick time. Yeah, let me open up my app, and I say code push sync. It's going to check for update, and it's going to say there is an update available if the internet cooperates, and then I can install the update, and I'll not have the error anymore. You know what? Let's park it for now. Let's go back to the slides and come back at the end of the talk when it finally has finished checking for updates. Oh, wow, there. Just when I moved, change my screens, there. So it says update is available. I can go ahead and install my update. It's going to install, download the package, which is again going to take time. Oh, that was quick. And it restarted the app. Now, if you notice, I didn't even have to reinstall my application. It was just code pushed. So I go in, go here. There you go. The bug is fixed. The subtotal is correct, and I can actually accept payments. Awesome. So that was actually fixing a live bug. So imagine that this app was on the App Store. This payment bug is actually a critical bug that's going to start costing you business, right? So that way, if you were to use code push, you can fix all of these bugs pretty easily, and yes, it is legal. And we saw, so this is pretty much all I had in terms of experiments and demos and crazy things that we built, but let me probably summarize what we did. So the first thing was, I showed you Mobile Center and Code Push. You can use Mobile Center today with CI. It's at mobile.azure.com. It can work with your React Native applications. In fact, if you have React Native libraries, like Max Stauber's style components, for example, you probably should use some sort of CI. I mean, you don't have to use Mobile Center. Use some sort of CI, and you'll be able to build this. You can distribute beta version of your applications to your testers. In fact, one of the other applications that I had here was the React Conf application, the React Conf conference application. So this is the one that the ThinkMill guys built. So they have like continuous integration setup, and if you look at their builds, their master is successful. There were a couple of failures. I mean, that's life. But yeah, so and their stuff was built. In fact, setting up continuous integration revealed an interesting bug in their case. The bug was they were doing snapshot testing, and one of the snapshots was about dates. However, if there were dates only, because it was snapshotted in Sydney, only dates in Sydney would work, or rather, if you had to make your test successful, you had to go to Sydney and run your tests. That was the only option. So I actually spoke to them, and they fixed it, and that's why the builds are green now. So it actually, like, it is a real-world use case, and it works for real-world scenarios. For all of you who know and love Code Push is eventually going to get integrated into Mobile Center. Code Push is going to be, you don't even have to worry about, hey, I have to go use my command line and use Code Push. No, you can actually say, when I'm building this branch, also Code Push it to my server. In fact, if you're using Code Push and you do not want to use any of Mobile Center, we want to maintain 100% backward compatibility, so you will not be broken at all. You do not have to make any changes to your existing Code Push application to move to Mobile Center. It's all going to be automatically taken care of. You can continue to use the existing CLI. You can continue to use the existing SDK. No changes there. In addition, we have crashes and analytics. I actually didn't show you analytics, so let me show you that. I can go to analytics. And this is, so it's not like Google Analytics where it's web-based. This is actually made for the mobile, which means that if your application crashes or if your application is offline and then online, all of those synchronizations are taken care of. You have like your daily active usage, you have total number of sessions, etc. You have your events. Actually, not on this app. It is on my app, yeah. Crashes, analytics, events. And this is, the analytics is integrated into the new React navigation library. Now, what that means is you just drop in the analytics library, and you'll actually start getting like page flows, and you'll see how many people, or rather how many times I've looked at the food screen versus how many times I've thought of purchasing it. So you can look at all of those workflows without having to even configure a lot of things. As far as code push itself is concerned, we are committed to furthering what code push is able to do. Here are some of the new things that are going to come into code push. The first thing is, today with code push, you can push out your updates to say 5% of the user or 10% of the users. In the future, we want to make code push usable for A/B testing, which basically means you can code push a certain feature flag to say people in Germany or people using iOS 6 or something like that. We are going to add support for code signing. This is something that a lot of people have been asking because your native applications are signed, but your JavaScript updates with code push are not signed. So we're going to add support for code push signing, which basically means the bundle that you upload to our servers can be signed and verified. And we are also working very hard on making code push work with hybrid applications, or the brownfield applications that Leland was talking about yesterday. So if you have just a plain native app and you bolt on React Native on top of it, code push is going to start working with that also. Yes, of course, find me and I can help you set up your CI app or your money back. Okay, the last part was just a joke, but I'm serious, if you actually have a React Native app, use some sort of a CI. It doesn't have to be Mobile Center. It doesn't have to be all the services of Mobile Center. But having a CI setup makes it look, so almost all web projects have it, right? And having it makes you a much more disciplined developer. So it's always good to set up CI. So please go ahead and set up CI. Or as I like to say it, setting up CI hasn't hurt anybody. It hasn't started fist fights, or it hasn't eliminated human race. So no harm in doing it. Why not just do it, right? And the VS Code story. So we try out VS Code for debugging and playing around with both React and React Native. VS Code has excellent support for Flow and TypeScript. My team is committed to supporting TypeScript with React Native, and we are doing a lot of work in that area. The extension that I had installed, it's called React Native Tools. And I forgot to mention this. Using VS Code, you can directly deploy to Exponent. So if you're actually working with Exponent, and Exponent is a great way to build your applications, zero setup, right? If you were to use Create React Native App today, you can actually do Create React Native App today, open up the app in VS Code, and start debugging your Exponent app from within VS Code. And that's like completely doable. It's actually production ready. The final thing is Node Chakra Core and time travel debugging. That's still a little bit of an experiment I've been playing around with. Time travel is always an experiment, right? You never know if you're going to come back from it. So it's an experiment. Maybe it'll be released, but if you want to play around with it, you just instead of running it on Node, you just download Node Chakra Core, and that's it. No other setup required. You'll automatically be able to get time travel debugging. So that's the VS Code story. And finally, oh yeah, by the way, VS Code has Vim bindings. And finally, the gesture mirroring stuff. That project is available on GitHub. It's called Mayakai. Mayakai in Tamil really literally means magic hand, and that's what this does. It's also still experimental, but it seems to work great for multi-device testing. Some of the use cases I've seen people use is, of course, it's a test recorder. So combine Mayakai with something like Jest, you actually get snapshot testing on your real devices. So it's a good way to write integration tests. A lot of people have been using it as a show and tell mechanism for your application. So remember that Mayakai is just a simple JavaScript code. It has no native bindings. So you can push this using code push. And if one of your users is actually stuck on, he doesn't know what to do, you can actually send your show and tell story using this method. The final thing is you can also set up a virtual device wall. So if you are able to deploy all of your applications with, say, Appetize or Exponent for that matter, or sorry, Expo for that matter, you will be able to just deploy them as a virtual device wall and start testing them, and this makes testing super simple. That's pretty much all I had. here's where my slides are posted. I also have a list of all the links that I spoke about. And as I said, I'm going to be around here. If you want to set up CI for your React Native app in 5 minutes, come talk to me, and I will not give you money back if I'm not able to do that. Thank you.